Welcome back, everybody. In this video, we're going to learn how to divide a polynomial by a monomial. And remember that a monomial is just a polynomial with one term. So notice in the examples we're looking at here, we're dividing something by just a single term. So that's what this video is going to be all about. Now, the easiest way, although there's different ways you can do it, but I think the easiest way to divide by a monomial is to just separate it out into different parts. So let me show you. So I'm going to take the thing that I am going to start with. So what I'm going to be dividing. And I'm dividing that by 2m, right? So that's what I'm dividing by. So we can write it this way as well. Now, what I'm going to do is I'm going to separate it out, though. So each term in the numerator is going to get its own divisor. So that 2m goes with both groups. And then now what you do is you simplify each piece separately on its own. So for instance, in the first group here, you have 6 divided by 2, which is just 3. And then you have m squared divided by m. Now there's different ways you can think of that. The shortcut way is to use what's called the quotient rule. So if you look at your two exponents there, so the top one has an m, has a 2, and the bottom m has a 1. If there's no exponent, there is always a 1 there. So what you could do with the exponents is you can subtract them 2 minus 1. So there's always, that's one way you can do it. And you always do top minus bottom. So this would be m to the first power, right? Because 2 minus 1 is 1. So that would be m to the first power, or you could just write it as just m. The other way you could think of it is to just think about it like canceling. So for instance, if I have m squared over m, well, m squared would be m times m. And you could also do it this way and think about, well, how many m's would cancel in each case? Well, I could cancel 1 m from both the top and the bottom. And again, you can see that I still have 1 m left over up top. Now for the next group, 2m and 2m are exactly the same. So just like regular numbers, when you divide something by itself, the answer is just 1 there. So these m's cancel, and 2 divided by 2 is 1. So our final answer here is 3m plus 1. All right, let's do another one. So here we have another division problem. This one's just written a little bit differently, where it actually has a division bar in there for you. You could write just a regular division symbol too, like one of these, although I will say we don't use it as often in upper level mathematics, but you can still do that. But I'm going to use the same strategy. I'm going to break this up. So I'm going to take the 9x to the 5th and divide it by 3x squared, the minus 12x squared over 3x squared, and then the 3x over 3x squared. And I'm just going to simplify them one piece at a time. So in the first piece, I have a 9 divided by 3, which is just 3. And again, you can think of this either by subtracting those exponents or actually just canceling it out. So if I subtract those exponents, right, you're doing 5 minus 2, which is 3. So this becomes x to the 3rd power. The other way you could do it is you could think about, well, if I have 5 x's up top and I have 2 x's down bottom, I'm going to cancel what's in common and still have 3 x's up top. So both of those are good strategies. Minus 12 divided by 3 is 4. Here, x squareds are exactly the same, so they will just cancel out. And in the last case, 3 divided by 3 is 1. And then here, you have to be a little bit careful. So again, you could either think of it like subtraction. So what happens is you'd have a 1 minus 2, which would be a negative 1. So that's one way to do it, is x to the negative 1 power. Now, what you'd have to remember in that case is that when we have a negative exponent, it does flip that piece to the denominator like this. So we'd have to rewrite it with positive exponents. The other way you could do it is you could think of it like this. Well, I have 1x on top and I have 2 x's on bottom because it's an x squared. And again, I cancel what's in common. And what happens is there's still 1x left on the bottom. So that's where that x is left over. So our final answer here would be 3x cubed minus 4 plus 1 over x. All right, so again, just really taking each piece separately here. And let's do one more together. This could be a great time when you see the next example to pause the video too and give it a try on your own. So see if you can work that out. And when you're ready, you can go ahead and start. So we're just going to go ahead and separate these out. All right, so in the first case, I have 16 divided by 4, which is 4. Now here I have 6 x's up top and only 2 in the bottom. So either 6 minus 2 is 4, you have 4 x's left over, or you could write it out and cancel, and you'll see you have 4 x's left on top. So that would be x to the 4th power. Here, 20 over 4 is 5. And then I have 3 x's up top and only 2 on the bottom. So either 3 minus 2 is 1. You could do it that way by subtraction, or you can write it out. You'll see 2 x's cancel, and you still have 1 left up top. Then the last one is probably your trickiest. 12 divided by 4 is 3. And then again, here you have more x's on the bottom. So what happens there is when you go to cancel, you do have an extra x left over, but it is in the denominator. So you can think of it that way, or when you subtract, you would get a -1 for the exponent, which would still flip it to the bottom. So in either case, again, you do have a leftover piece here. Okay, let's do one more. I'm just going to spread it a little bit here with multiple variables. All right, so same thing. We're taking a polynomial and we're dividing it by a monomial, so just a single term in the bottom. And one of the easiest ways to do this is just to separate it out and take it each piece one at a time. All right, in the first group, I see 8 divided by 4, which is 2. Now I have x squared over x. So what happens there is I'd have 1x left up top. Again, you could either do it as the exponents. 2 minus 1 gives you that 1x, or you can just cross out those that are in common. And same thing for the y's. So you would have y to the 2 minus 1, which is y to the first power. Remember, if you're doing the subtraction technique, it's always top exponent minus the bottom exponent. If there's no exponent written in there, there is always a 1, so you could add that in. And if the answer is positive, it just stays in the numerator. The only time it's going to flip to the denominator when you're subtracting like that is if the answer was negative, the exponent. In the next case, I have 16 divided by 4 is 4. Now notice here that the x's and the y's are both exactly the same, so they're going to cancel out. In the last case, you want to be a little careful. So this is 2 divided by 4. It is not 2, right? 2 divided by 4, if I divide both parts by 2, gives me 1/2. So just be really careful when you're doing your simplifying here. So this one stays a fraction. So it's going to be 1/2. Now the x's do cancel out. They are the same, but there's still a y left over in the denominator. So I can go ahead and write it like this, 1 over 2y. Now you can always check your work as well by multiplying it back in. So again, if you want to go ahead and do a check, which I'm not going to do every single one, what you do is you take your divisor and you multiply it by your answer. And this works for all the problems we've seen as well. So you just multiply it back in and just check that it actually works. Remember, multiplication and division are opposites, so you can use the strategies to check your work there. If you multiply it through, 4 times 2 is 8. X and x is x squared. Y and y is y squared. Here, 4 times -4 is -16 with an x and a y. And then in my last case here, I have 4... I'm going to write this one out. So 4xy times 1 on the top is just 4xy, and I still have a 2y in the bottom. And if I simplify that piece a bit more, 4 over 2 is 2. I have an x left over, and the y's cancel. And you can see that it does match the original numerator here. So if you're unsure if you made a mistake, multiplying it back through is a great way to check your work.